Okay, I think it should be back up. Let me do this. That's not the right window. That's the right window. Let me put the chat back on my screen where I can see it. And then I gotta do this. Alright, so let me test this, because I was testing it earlier and it was working. Yeah, there we go. Okay. I don't know what happened there. Apparently my tablet crashed, and when it did that, it lost the configuration file that says, hey, I only want to write on one monitor. So I was trying to write in the center of the tablet, and it was shoving my cursor all the way to the left, which is why stuff was highlighting in the chat and things were moving around like this, because I was clicking over there without realizing it. So let me see if people are coming back in. Let me hide this because, yeah, it looks like I have 4 people in here. I don't actually know how the stream works, like when an old one goes down. Like, I don't think it comes back up. I think you have to open it up again. So, if anyone is in the old stream still, and this one, tell people to refresh the page. And I'll type that in the chat here. I guess I can send out another announcement, too. Oh, I don't canvas open on this. I mean, who knows when this announcement will actually reach people, but let's try this again. So, Q&A stream is back up. If you are watching the old one, please refresh the page or find the new stream. And we'll send that to everybody. You posted on the Discord. Okay, thank you. Yeah, the more places that gets around, the better. So save. Unfortunately, when I do announcements, I have to do like 36 steps because I have to push this one announcement to all of your pages. Otherwise, I got to do it 4 times, and that takes longer. But what that means is that it's going to take 2 minutes before the announcement actually posts and the email gets sent. So, okay, we can put this back on the screen. Let me just write down what I had on the screen here before we were so rudely interrupted by technology. So we had this. Now, the sad part about this really is that there are a bunch of questions that were asked and I don't remember them. So people are going to have to ask their questions again so that they're in the chat, because all of that got lost when my video went down. I think we were around here. Yeah, I apologize for that. I don't know what happened with my driver other than computers just being silly. F, G, and J. So I remember F, and oh goodness, now my cat's going to bug me. Okay. And somebody asked for L and P, and then there were like a few specific questions about the lab that I only sort of remember. How many people are back? Okay, it looks like most people are back in here. Okay, cool. Okay, cool. Thank you. Yeah. We'll get to each of those in turn here. All right, so now what I'm going to do is I'm going to take my conversions like before. I'm going to put those up into the expression up here once I've set up all my units. Oh, okay, good. That announcement actually went out when I intended it to. It was set for 228. And so you should set up your numbers like that so that they line up with the conversions that you've written down. If you are having trouble setting up the problem, remember that you can do this sort of diagramming or blueprinting down here, and that will help you tremendously. This might be the important part of the problem to get the solution, but the setup is important. Like, you don't just go into drawing and create, like, the Mona Lisa without doing at least a little sketching, right? Like, you got to figure out where in the center of the painting she needs to be. It's the same thing with doing these types of problems. You can't just dive in and get the answer. If you could, then that would be way easier and nobody would have to take this class, right? So do the setup if you need to. Figure out what unit you start with, and then figure out what unit you're trying to go to. So I'm going to punch all these into my calculator, and the number that I get is a really, 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 really big number. So I got to write this sideways here. Or I'll actually, you know what I'll do? We'll get rid of this guy. This is what my calculator says. That should be a 0.8 there. And then finally, looking at this number, we got to figure out how many sig figs we should have. So this number right here is 4 sig figs. This is 6 sig figs. And this is an exact conversion. So our answer should have 4. So we do that. Now, obviously, I can't just write this as my answer, because 1,308 is not equal to this giant number. So the rest of these are actually going to become zeros. Or we could do scientific notation, which would be 1, 2, 3, 4, 5, 6, 7, 8. Like that. Okay. Yeah, I can answer all of these. Let me go through them in order. So I'm going to start at the top here. We'll do F, G, and J. We'll do a few from L through P, and then we'll start talking about the labs and percent error and stuff. How did I get 10 to the minus 3? So this one right here. So that number comes from the chart in Unit 2 that talks about metric prefixes. Let me find what slide that's on. Oh my goodness, my cats. They're so lonely, you guys. So lonely. Maybe it's not in Unit 2. Maybe it's in Unit 1. Or is it in Unit 3? I don't actually know. Oh, it is in Unit 3. Okay. I have no idea if this is... Oh, it sort of is showing up on your screen there. There you go. So on the right there, you can see this is slide number 6. There's a giant chart of metric prefixes, and this is where that 10 to the minus 3 comes from. That's for milli. And so you got to know those prefixes. You got to have those on hand to reference. All right, let me go back to this one. Yeah, it's just that when everything is going wrong for me, like when it rains, it pours, right? And now my cats are just like, oh my goodness, I want to go outside. Like, I live in an apartment. No, you're not going outside. All right, so that was problem F. Let's do problem G, which is very similar here. And so we're going to turn 575. That looks kind of like a 6. Let me do that. 1,000 milliliters to quarts. And then we'll go back to that Google page that I had open, and we'll type in... Oh, actually, you know, let's figure out what units we want to do first. All right, so this is our goal here. So let's figure out a way to get from milliliters to quarts here. Milliliters is kind of tiny, so we're going to turn that into liters, because liters sort of goes everywhere. And then you could do liters to gallons to quarts or whatever. I think there's one that's directly liters to quarts. So, same relationship with milliliters as there was for milligrams, as shown. And then for liters to quarts, we're going to have to go to YouTube, not YouTube, to Google. So 1 liter to quarts. They're roughly the same thing, I believe. Yeah. To 2 sig figs, they're almost essentially the same. So 1 liter, 1.05669. We don't need all of those sig figs. So we'll do that. Yeah, don't worry about a 10-point quiz if you only got 5 out of 10. It's a 500-point class. Like, it's not a big deal. I know you guys are in the high school mentality of OMG, I have to get every single point ever. Non-college. Don't expect to get every single point ever. Because there's just too much to know. So we'll set up our units using the blueprint down below so that they cancel out as we go. And they'll leave the end unit that we want, which is quarts. And then I need to fill in my information, so I'm going to take this and put it here. Just line up the numbers. Again, that 10 to the minus 3 is from that chart in Unit 3. And then this relationship right here, we just got off of Google, and it's right there on the screen. So 1 liter is 1.05669, which we'll just do that, quarts. Ah! I keep bumping the mouse, and then it goes to the bottom right of the screen, and then it minimizes, and everything disappears for me. I think it's still on the screen for you. Otherwise, you're seeing my desktop. It might work on a motorcycle. Times 1 times 10 to the minus 3 times 1.057. Enter. When I did that, I got 607.775 quarts. Which, of course, that's too many sig figs. This number as written, 575000, all those zeros are placeholders. So that's only 3 sig figs, so I'm only going to keep 3 sig figs here. So I would actually answer this as 608 quarts. All right, I got to move this over here so I can see. Okay, so a bunch of people want to see J. Oh, I didn't mean to right-click there. So we'll do J next, but I'll leave this on the screen here for a second. Are there quick questions I can answer that I don't need to actually write down? So with regards to the lab and describing liquids that are textureless, textureless is a very good word to use. So, like, water has no texture in it. If it does, you should not be drinking that water. So you can write that for any substances that are just have zero opaqueness to them. That's totally valid. For the chemicals in the introduction, like the unknowns in the bottle, some of the bottles are foggy. I think all three of them are, actually. So it's hard to tell, but I pour them into test tubes at the very end of the video. And then I mix the sodium tube into the other two tubes. So you can see those in the stand. I just didn't bring it forward because I didn't think to, and that's my fault. Oh, it's absolutely okay to repeat yourself because I realize there are a lot of liquids out there that look like water, and if I asked you to describe them all uniquely, you'd have a problem because they all look the same. It is totally okay to use the same descriptions for the individual reactants before they are mixed. If you can distinguish them, do so, but for the most part, it's hard to do that. And that's kind of the point. It's like in the pre-lab where I talked about, here's sugar and here's methamphetamine. Can you tell them apart? They're both white crystals. And the answer is, by looking at them, maybe not. There is a possibility that one could be recrystallized in such a way that it confuses the person looking at it. Now, if you could taste them both, you go, wow, one is really sweet, and I actually don't know what meth tastes like. Oh, damn it, I really missed an opportunity to say. One is sweet, and I don't know what sugar tastes like. But, yeah, I don't know what methamphetamine tastes like, but taste would be a chemical reaction that you could use to determine the difference. You could also use other chemical means, which I talk about. But with your eyes, you don't have that option, so if you write down the same thing, that's okay. I'm at the bottom of the page, so we'll go back up to the top. And I'll just select all. Alright, so let's do problem J. For this problem, we need to turn... Oops, not 7. A compound ratio into... another complex ratio. Be as descriptive as you can, but I realize that there's going to be a limit on clear and colorless solutions. Alright, so there we go. For problem J, you have to do 2 conversions to get to the target units, which means that I need to turn pounds into milligrams and gallons into deciliters. So pounds is easy because we can turn pounds into grams, and then we can turn pounds or grams into milligrams. So that's not a huge deal. Gallons isn't so bad either because we can turn gallons into liters, and then we can turn liters into deciliters. But we need to do both of those at the same time. So let's go look up all of those relationships that we need here. I don't want that tool. 1 pound is 453.6 grams. 1 milligram is 10 to the minus 3 grams. So that's these relationships here. Gallons to liters, I don't have that on the screen. Let's go look that up here. So 1 liter to gallon. So that would be, I'm going to just scroll this down just a little bit for a second. 1 gallon is equal to 0.2642 liters. And then finally, for liters to deciliters, if we look this up in that chart, a deciliter is just 10 to the minus 1. Oh, you're right. I can't see. I'm looking at that screen and I can't read the numbers, and I'm not thinking about it. So, thank you. Yeah, that doesn't make any sense. So 1 liter is this many gallons. Thank you, good catch. I can only read the numbers on my screen. The rest is just pixelated out. So now that I have all 4 conversions out, I can set up my problem. We're going to do that up here. So let's start with what we've got. And then for our first conversion, let's take care of this top row first. We'll turn pounds into grams by doing that. And then we'll turn grams into milligrams by doing that. So now I have milligrams on the top, so that part's done. Then we'll change the gallons on the bottom into liters by putting gallons on the top so it cancels out. Remember, you can cancel these any distance. All that matters is one is on the top and one is on the bottom. We'll turn gallons into liters. And then we'll turn liters into deciliters. What the heck is a deciliter and why do we use it? Milligrams per deciliter is a common unit when used for blood analysis. So if you are hypoglycemic or you have diabetes or something like that, they measure your blood sugar in milligrams per deciliter. I believe it's blood sugar anyway. So now that I've got this and this in the right spots, and those are the only units that are left, my answer when I put all the numbers in will be in milligrams per deciliter. So let's put all those numbers in. 1 pound is 453.6 grams, so we'll write that up here. 1 milligram is 10 to the minus 3 grams. So we'll write that in. 1 liter is 0.2642 gallons. And then 1 deciliter is 10 to the minus 1 liters. So I got that, and then divided by 1 times 10 to the minus 3. And I got 10,438.16. So equals that, which we then had to do sig figs for. Where's my, there it is. So this has 3 sig figs. This is 4 sig figs. This is 4 sig figs. The rest of these are exact because they are definitions. So my answer should have 3 sig figs. And there you go. All right, questions on that one? Let me make sure I got all the questions here real quick. So J and then L through P. I'm going to do L and then I'm going to do N. And then we'll do P. I'll do L, N, and P, I think. Because I don't want to do all of the problems because then you don't actually do the practice. But I have a bunch in here that are similar. Like I tried to give you 2 of each type, so I can do 1 of each of those. Just in the interest of time. But like at the end of the period, we can come back and do them. Okay, so let's do problem L. I'm not quite on the screen here. Hold on. So I want to do gallons per minute. And so same setup as before. We're going to turn our starting units into our end units. Now, I already have liters to gallon on the screen, so that's an easy one to do, provided that I don't mess up the numbers again. And then how do I do seconds to minutes? Well, that's pretty easy, right? That one's a definition. So those are going to be my two conversions here for this problem. So we'll take this number. And we'll set it up so we start canceling these out. So I'm going to start with the liters down here. So cancel out liters. We'll turn that into gallons. And then I got to cancel out seconds down here by putting it on the top so that it cancels with this one. And then those are the units that are left, so those will be the units of my answer once I do the numbers. So now we just take these numbers and fill them in. So here's liters to gallons, liters to gallons. And then here's our time, minutes and seconds. And let's punch it all in the calculator. 38.264260. And I got 116.98776. That's good enough. So then when we do sig figs here, or this is counted, so it's infinite sig figs. The lowest that we're going to have is 3, so I would keep 3. And there you go. How do we feel about these now, seeing a few more of them? I'm not sure if my chat is updating. Oh, there's somebody. Okay. It was just very quiet for a moment there. I was like, oh no, am I alone? I can go check that at any time, but they'll just do that. Okay, yeah, I have 20 people in here, so that's still working. So you can actually use any conversion you want to, as long as the conversion is valid. So what that means is that on the screen right here, oh, there we go. Now you can see me pointing at it. I have 1 liter to gallons, but let's suppose that I had the 1 over here. Then this would happen. And you'd have 3.78541 liters equal 1 gallon. Well, if I go back here, let me get a different color to indicate that we're doing something different here. Let's do like blue or something. Let's suppose that I used this conversion instead for this problem. So I would put this in the place of the conversion that I had. Well, it turns out numbers have an interesting property. If I divide by this number, it's the same as multiplying by this number. Kind of like how dividing by 2 is the same as multiplying by 0.5, right? They're both half, yeah? So when you get a different conversion, what you're actually finding is the inverse. So if you found the conversion I wrote in blue, and you're using that, and then you went to this YouTube tutorial and saw, oh, he's using the pink one. Am I doing it wrong? The answer is no, you actually get the exact same number. So as long as you find a conversion that is valid, and Google won't have any mistakes in its conversions because they've been checked multiple times by scientists and instructors like us, and we would have pointed it out long ago. But as long as you are using a conversion that is correct and then putting the numbers in the right spots, then you're in good shape. And as long as you set up all the units correctly by putting them down first, like we've been doing all along, then you'll know exactly where to put the numbers. So this is kind of like a whole blueprint approach. Like, set up everything, put on all the scaffolding, and then fill in all the numbers, and you're all set. Oh no, I don't know if you can hear him, but my cat's right here. He's so lonely, you guys. I don't have enough space to do the next problem. So, we're going to go on to the next problem, which is N. We'll do N and P, and then we'll take a break, because it'll be at the top of the hour. And then when we come back, we'll just keep going. So, let's erase. Let's do problem N. And I guess we're going to have blue as our color for a little while. When I change colors here. Problems M and N deal with squared relationships. This is a very easy relationship that I'm sure everybody knows here. 12 inches is a foot. I've unfortunately cleared the screen, so I don't know what you mean by going from 1 gallon to 60 seconds. But remember, when you are doing these unit conversions, you're always setting them up so that you do something like this until you cancel out the units that you don't want and leave only the units that you do. And then if you have another unit on the bottom here, you can cancel that out by doing something like that. So your first step for setup should always be set up the units in the relationships that we identify down here so that you can get the answer that you want. All right, I have this relationship here, but that's not exactly what this is asking for, is it? Why is this not writing? Oh, because I have it. I have to do that. This isn't exactly what I want. I want inches squared to feet squared. So how do I do that with this right here? Well, if I take each side and square it, I will then get the correct relationship, which would be whatever 12 squared is, which is 144, equals whatever 1 squared is, which is 1 feet squared. So remember, in order to change the dimensionality of a relationship, you have to square all the numbers or cube all the numbers or whatever it is that you're trying to do. So when I go up here to do my conversion, and we'll just actually do this over here. This inches squared doesn't actually cancel out with this inch. What would end up happening is this would happen. And that's not quite right because we'd still have an inches left. So I need to square everything. And then I can put in the relationship like this. And then I would square everything. Or you could do the problem like this, which is, well, I just did all of this work over here for that, so I'm going to just write inches squared and feet squared over here, and just put 144 directly in. Either way works, but just remember that when you make a two-dimensional unit out of one-dimensional units, you gotta square everything, including the numbers and the units. So 260 divided by 144 is 1.805. There's only 2 sig figs here, so we're just going to do 2 sig figs because of this guy right here. All right, that was problem N. Problem P puts everything together, but I'll give you a second to finish copying that down and maybe come up with a question if you got it. How many questions are on the quiz? This week's quiz has 5. And they're more like story problems than they are these types of problems, although some of them are like this with an associated story, like so-and-so goes to the store and walks this many kilometers. What is this distance in this made-up unit that I just created? Use this conversion vectors, something like that. So they're pretty representative of the problems on the worksheet and the homework, because I looked at the homework exercises when I... Oh my goodness. I don't know if you can hear the beeping outside, but... I looked at those problems when I was writing the quiz, and I was like, okay, I'm going to just make this problem like that. And I specifically picked problems that I assigned for you, because that's kind of the point. Where's my cursor? There's my cursor. So, let's do problem P. Yeah, we're going to definitely go over some of the word problems, probably after the break, since it is... Where's my clock? Yeah, it's currently 3, so we're going to do problem P, and we'll take a short break, and then we'll come back and do more problems. I just wrote s squared because I was using a velocity or an acceleration, but that's okay. So I want pounds, miles, minutes squared. All right, these units are silly. And this basically requires us to do everything that we've been doing so far and more. So, oh, I don't have any more room to put that down. So I'm going to do this. I'm going to put kilograms, I'm going to put meters, and then I'm going to put seconds squared on the bottom. And you'll see why I'm putting them kind of offset like this in a second. So there's our 3 relationships that we got to change. We got to change kilograms into pounds. Well, that's easy enough. We can do that directly. And so it's like 2.204 pounds is a kilogram. Meters to miles, that's a little harder. So I'm going to do meters to kilometers to miles, although meters to miles I'm sure exists. So 1 kilometer is 10 to the 3 meters. And then for kilometers to miles, I want to say that it's this. You know, if you weren't sure, just look it up on Google. Let's do that. Where is that? 1 kilometer to mile. So there's the relationship, but I actually had 1 mile to kilometer, so we'll just do it that way. 1.609. And if you have that relationship, you can use that too. 1 meter is 0.0006213 miles. And then finally down here, we have seconds to minutes, but they're squared. So if I say that there are 60 seconds in a minute, I'm going to have to square that. I know that that sounds really stupid. Why would you have square seconds? How do you square time? And the answer is, in reality, what that is per second per second. So an acceleration is per second squared. And if that doesn't make any sort of sense to you, that is totally okay. I didn't really understand that until we started calculus and physics, so don't worry too much about the origin of square seconds. Why 4 sig figs? These are what I have it memorized to 4 sig figs. Also, our answer only has 2 sig figs in it, or our starting value only has 2 sig figs in it anyway. So, as long as I'm above 2 sig figs, that won't really affect our result. So now I have all the information written down here. So I'm going to try my conversion here. And so what we're going to do is we're going to set it up just like we were doing before, but we're just going to cancel out one thing at a time. So let's do this first step right here, kilograms to pounds. To cancel out kilograms, I would have to put it down here. So that one's done. Now I'm going to turn meters to kilometers to miles. And you could do this in one step if you wanted to. So there's that. And then we'll turn kilometers into miles. So that one's done. And then I got to turn seconds into minutes. So seconds is on the bottom, which means that when I put it over here to cancel it, I got to put it on the top. And we got to square the whole thing so that I get seconds squared. So this seconds will square and cancel it with that one. And then I will have square minutes at the bottom. There are 60 seconds in a minute, but 60 squared square seconds in a square minute. And again, I realize that sounds stupid. But units are weird and don't always have a physical meaning, so don't worry too much about that. So now we can go back and fill in all the numbers here. So pounds per kilogram, I realized that I had already started doing that kind of. Kilometers and meters. Miles and kilometers. $1,800, 2.204, 60 squared, divided by 1,000 times 1.609. And I get to sneeze. Hold on. Oh, maybe not. But the answer I got was 8876.27. What are my units here? Pounds. Let me just circle them so I can see them here. Pounds per mile per minute squared. And then, of course, we have to reduce that down to the correct number of sig figs, which ends up being 2. And so this would be 8,900 pound miles per minute squared. I have no idea what that number is. What that 8.4 times 10 to the 19 number. So specifically for this problem P that we did, sure, we could talk about that. So here was our here's where we were starting up here at the top. We wrote down what we needed and where we were going. And so down at the bottom, I then started converting. This should be kilograms. It looks kind of weird. I started converting the units to the target units as shown. So I can turn kilograms into pounds. That's easy enough. I can turn meters into kilometers into miles. That's easy enough. We can do seconds into minutes because that's pretty trivial. And then to get squared, we just square everything. So if I had to write out a blueprint for how to do this, so step one, I would say write out the unit map that helps you. Oh, over here, I am only squaring the 60 seconds, because if I squared everything, then this would square, and this would square, the units would square, and that's not what I want, because those are not the units of the answer I want. So I'm only squaring what's in the parentheses here. I don't know what went wrong there. Did you use parentheses around the number on the top? Is my best guess. Or you times by 1.609 instead of dividing. Make sure you're using parentheses when you type stuff in for the bottom. So, actually, let me just finish what I was writing here, and then I will write in what I typed in my calculator to get that. So step one, draw the unit map, which is this. That gives you all of your conversions that you're going to put in the top there. So step two, set up the units to cancel, not cancet, cancel stuff. Oh. Yeah, this is pretty universal how we do dimensional analysis. It's really important to do it this way. And once you get the hang of it, you get the hang of it. It's pretty straightforward. And then step three, fill in the numbers. Okay? This is how I do it every time. And you might think, oh, wow, you have to draw out the unit map every time? And I'm like, yeah, because I want to make sure I get the right answer, right? So this is the organized way to do it. When you get proficient, you don't actually have to do step one. You could just do step two and step three. But I do steps 2 and 3 every single time. I don't try and take any shortcuts at this. Because how could you? There's so many numbers in the way. To try and figure out where the issue was with the calculation, I'm going to type in what I typed in my calculator. So I typed in parenthesis 1800 times 2.204 times 60 squared, close parenthesis, divided by, open parenthesis, 1,000 times 1.609. Enter. So that's what I typed in to get that answer. Now, the most important part is those bottom parentheses, because if you don't put the bottom parentheses in, remember your calculator just does operations in a straight line if they're all equivalent. It'll do the top part, and then it'll divide by 1,000, and then it'll say, oh, you want me to times it by 1.609, not realizing that it wanted you to divide by that multiplication. That's what I figured was happening, because that would make you get a bigger answer if you multiplied. So be careful when typing in stuff on the bottom of an equation, and always, if you're worried, just use a ton of parentheses, because the worst thing that will happen is that you're wasting your time putting in abundant parentheses. Like if you do this on your calculator, it'll look at that and it'll just go, oh, okay, whatever. I have a bunch of parentheses. It doesn't even care if you If you just do this, like it'll ignore open parentheses. The problem that occurs is if you have too many closed parentheses, and then it'll tell you that's a syntax error. Because it'll go looking for a previous open parenthesis to pair it with. Alright, that's problem P. And we're definitely due for a break. We're going to do a shorter break. We'll do 5 minutes for today, just because I want to have more time for you guys to do these problems. If I missed any of these questions in the chat, let me know over the break, because the chat will pop back up. So instead of 10 minutes, we'll actually do 5. So let's actually just update that. There you go. And we'll put the timer up. All right, so I'll start that. I'll turn on the Mario music again, and I'll see you in a bit. Oh, I tried to tap the button a second time. I can't tap it in 0.1 seconds, though. That's ridiculous. I want that on the screen, and then I want that on the screen. All right, so there was a question over the break. Do I have to do the first step where I'm drawing all these expressions out? Can I just go straight to the top part up here? And the answer is, yeah, you could totally just do the top part. So step 1 is kind of optional, but if you're really stuck and you look at a problem, you're like, I have no idea how to begin this. Draw the unit map. Turn each unit into another unit, 1 unit at a time, until you get to the target unit that you want. Let me see here. I need to check to see. So we did all those. Did that. There was a question about the pre-lab for lab number 1. What that question is asking is that if you use that grid, you can see the results of what things do when they get mixed together. And that'll tell you the answer. So, like, in the column marked A and the row marked B, the intersection is what the result of mixing those two things is. Can I do problem O? I can do problem O, but do people want to do the story problems too? Because we can come back to O if we have time. We only have about 40 minutes. I did want to do a few of these story problems. Select all. There. Issues with 5 and 6. Yeah, let's do those first, and if we have time, we'll come back to O. Okay, so... I have no idea if that's on the screen yet. So let's do this. And then this, we could just turn this off for now. So let's look at problem 5 here. That's a good problem to start on. There's definitely a problem similar to number 5 on the quiz, so this is a good one to review. Alright, so problem number 5 says the speed of light is 3. I'm not writing on the screen where you guys can see it. Hold on. Is 3.00 times 10 to the 8 meters per second. And it takes a photon of light approximately 500 seconds to reach the Earth's surface. How far away is the sun in miles? So when you see problems like this... Oh, you're welcome. Thanks for coming by. Let me know if you have any questions over email. For problems like this... Oops, don't accidentally draw on the tablet. What you want to do is you want to identify what the goal of the problem is. So the goal is to answer the question, how far away is the sun in miles? And so in order to do that, we're going to make our little blueprint again. Our goal is to get to miles, but we have to get there by using some aspect of the problem that is given to us. So I know what this is. This is a speed. And this is a time. And I can relate speed and time together in some way, and the goal is to get miles out of that. And so the point of these problems is for you to figure out how do you make that transition from time, which is a duration that we measure, to distance, which is a length. And the answer to that is, well, if I start with time, so if I start with seconds, I could then use this relationship to turn seconds into meters. Because using a speed, would turn an amount of time into a distance, meters. And then I would turn meters into kilometers and kilometers into miles like we've done before. Where there's 10 to the 3 meters equals a kilometer. And there's that many kilometers in a mile. So if I start with the units of time, I can turn time into a distance using the speed. And then I can turn that distance into the appropriate distance that I need. So looking at these types of problems, your goal is to try and figure out, okay, what's my starting point and what's my ending point? Usually the ending point is easy enough for you to do. But at times, the starting point can be obscured. Now, it's not always guaranteed to be this, but most of the time, if you are just given a number that does not have like a division, it doesn't have per in it or something like that, that's almost always going to be your starting value. Like in the next problem there, you can see on the board for all of those relationships that I give you for Grimm and his motorcycle and his wallet and all those things. So like his motorcycle holds 10 gallons of fuel. He has $200. This is what the exchange rate is. This is the cost. Like, some of those numbers are just numbers by themselves, and the other ones are relationships. You want to find the number that is by itself, and that's what we'll start with. So let's try and solve this problem. We're going to start with 500 seconds, and we're going to convert that into, according to this diagram down here, we're going to convert that to meters by doing that. And that's where my speed of light will go. It'll be 3 times 10 to the 8 meters per 1 second. So now we're here. We're going to turn that into kilometers. And then I'm going to run out of space because I didn't plan this ahead well enough. We'll do that. So kilometers. Oops, that's not where that goes. You know, let's not do it this way. I have a computer. We'll just do this. And now I have plenty of space. Look at that. And there you go. So now that would give me a distance in miles. Now I just got to fill in the numbers from below, and so that's where these come in. So in 1 second, light will go 3 times 10 to the 8 meters. There's 1,000 meters in a kilometer. And 1 mile is 1.609 kilometers. So when we type this all in the calculator, and again, be careful with parentheses. You should get 93 million miles. So I got 93,225,605. And since our results have, so here's 4 sig figs. This only has 3. This is exact, and that has 4. So our answer will go to 3. Do you need to use scientific notation? You don't need to do scientific notation if you don't want to. But in some cases, it helps. 3, 6, 7. If your number is very large, I will tell you to put your answer in scientific notation in Canvas. And then I will tell you how to do that. Because I actually had to do that for one. There's like 15 different types of problems that you'll see on the quiz. Ooh, excuse me. But you'll only be assigned 5 of those problems. And in one of those problems, I had to do scientific notation because you just got giant answers. So I set it up so that you could type it in scientific notation, and then it would automatically go boop and enter your number as in standard notation once you've done that, and then that would be fine. All right, so that's how you do problem 5. Really, the trick to these problems is figuring out how to get to that blueprint. And that's where the blueprint's really helpful, is because it can help you organize your thoughts. All right, so let's do problem 6 here. I scrolled down too far. Okay. All right, so we got a bunch of stuff that we need to write down for just information here. So now you might look at this problem and go, what the hell are you telling us all about your stupid orc about? And like the year that this takes place in, and that he's a gang leader in an orcish motorcycle gang. The reason that I'm doing that is because I'm filling the problem with bogus information that isn't relevant for a reason. And that is that, one, in the real world, when you are looking at a problem, problems don't come up to you with all of the information just right out in the front. It's sort of obscured in the context of what you are looking at. So an important skill to develop is to, like, how do you wade through all the crap? And I know that a good strategy that students follow is they just take their pen and they just draw lines through everything that isn't important. So, like, do you need to know what type of motorcycle he rides? No. Do you need to know how much the fuel tank holds, though? Yes, that's important. So, either, like, highlight the important stuff or cross out stuff that's not important. Whatever it takes for you to get the context of the problem narrowed down. Because in the real world, you're going to have to actually do that when you analyze a problem. The second thing is I like to talk about my org. So for problem 6, what do we know? So we know that the fuel tank holds 10 gallons. And we also know that fuel is 2.75 new yen per liter. He has $200 on him. And the exchange rate is $1.46. Will get you 83.5 cents in new yen. I actually just made up the exchange rate. Just for the purposes of the problem, because when I make these problems, I just type in random numbers, and then I solve the problem. And then I try and get it so that the answer is close to whatever the breaking point is. So the breaking point for this is $200. If the gas that Grim needs to buy is more than $200, he can't afford it all. If it's less than that, he can. So that's the point of the problem, is to get you to distill this down to yes or no. But in order to do that, I don't want the problem to be that, oh, gasoline costs, for this problem, costs $37,000 and he has $200. Nor do I want it to be, oh, it cost $1.07 and he has $200. I want it to be kind of close so that you have to think about the answer at the end. So that's where these numbers come from, is I had to just pick something to make it up. Now, for this problem, there's 2 ways to do it, and we're going to do both of them. So here is method 1. Let's start with money. I know how much money I have, so I'm going to turn my amount that I have in dollars into new yen, using this relationship here. And then if I do that, I can figure out what volume of gas that I have. And then finally, I can turn that into gallons. And if I get a number of gallons that's less than 10, or oops, sorry. I wrote the wrong symbol and then I said the wrong thing. If I get a number that is greater than 10, that means I can afford to buy more than 10 gallons. And yeah, generally speaking, you're right. For the exchange rate, it's just 1 to something. Now, for the second method, what we can do is we can go the other way. We can say, okay, I need 10 gallons. How much does that cost? So I'm going to turn that into liters. Then we'll figure out how much that costs me for a price. And if the cost is less than 200, we're okay. Okay? Either of those methods will work based on this problem. And that's kind of unique because I gave you 2 numbers to work with. But you have to look at those 2 numbers and compare them to each other. Can I buy 10 gallons with $200? Or how many gallons can be bought with $200? And you can choose either one. So what I'm going to do is I'm going to use method number 1. We're going to start with the money and see what maximum amount of gas can be bought. Unfortunately, number 1's going to scroll off the screen there, but that's okay. All right, so I'm going to start with $200. And according to our chart, which is off the screen, that's okay. We're going to turn money into a different form of money. And then we'll turn new yen into liters because we can figure out the cost per liter. And then we'll turn liters into gallons. And now I just got to fill in the numbers for the relationships from the problem. So I know that this conversion exists. So $1.46 will buy that many new yen. According to the problem statement, gas costs $2.75 per liter. And then I got to look up the conversion for gallons to liters again, which I don't have. So 1 gallon to liter. And we can turn this back on to get that on the screen. So it's 1 gallon is 3.7845 or 54, sorry. 1 gallon, 3.7854. All right, we don't need that anymore, so we'll just close that off. And so now, this should tell me the number of gallons that can be bought with $200. So punch it all in your calculator. Again, be careful with parentheses because there's a lot of stuff on the bottom. So when I did this calculation, I got 10.988 gallons. That's larger than 10 gallons, so that means that Grim will have some money to spare when he's done. But we have to worry about sig figs. None of these are exact. So the lowest number that we have there is 3. So if he can buy 11 gallons and his tank holds 10, he'll have enough money to fill his tank. Now let's do the problem the other way. Let's start with the amount of gas that we have and then convert that to money, just so you have a second way to see the problem. And see how much it costs to buy 10 gallons. So we'll do that down here. So this will be number 2. So we'll turn gallons into liters. And then from liters, we can get a cost for that. And then we can turn that into the money that we're familiar with. And so now I'm just going to put in all of these in reverse, really. So 3.7854. 1 liter is 275. And then 146, 0.835. The other reason that might make the exchange rate weird is so that you don't end up with a problem where you're just multiplying a bunch of numbers together and get all the ones on the bottom. Because you'll notice that if I put 1 for Nguyen, you'd have to put the 1 somewhere, and then it'd just be multiplying all the numbers together. And I'm trying to avoid problems where all you do is multiply. Because then people get the idea, oh, I just multiply all the numbers that are shown together, and that's not right. You do have to set up all of the units every time. I'm going to have the same number of sig figs as before, since I'm using the same numbers. But there you go. That's the cost for 10 gallons. That's less than Grimm's budget. So he can afford to fill his motorcycle. Now, if you had to spend $182 to fill your gas tank every time you filled up the car, might not be great, huh? Well, better hope for a hybrid. All right. Any questions on problems 5 or 6? I think problems 4, 3, 2, 4, 3, and 2 on the worksheet are just slightly easier variations of these problems. But you should definitely do them. Does painting the Harley red make it go faster? It does, actually. I think Grimm's Harley is actually just black. His jacket has red and purple on it, because those are the colors of his street gang. Yeah, word problems are the worst, but the problem about that is that they are the type of problem you actually encounter. Like, you don't go outside and then to open the door you have to solve for X, for example, right? Like, word problems are just how we see stuff. We condense things down into equations to make them easier. And so the skill we're trying to develop here is to get you to take a giant paragraph with all these numbers and words in it and actually distill the information out. Needs a spoiler for plus 10 horsepower. I don't know about that. His bike is pretty yearsed out. Yearsed is the Orcish word for bling. Oh, I definitely have problems with my words. All right, what problem do we want to do next? Do we want to go back and do problem O? I'm just rearranging the screen here. Is problem O still on the board? There it is. We'll do problem O, and then if there aren't any more questions, we will call it a day. Ah! I don't know why it was shifting that much. All right. Boop, boop. So this is a pressure problem. The units of pounds per square inch is a measure of pressure. So like air pressure or atmospheric pressure or water pressure or something like that. We'll use those units. Yeah, if you have lab questions, let me know. Just keep typing them in the chat. I'll go through this problem in the meantime. And just to get our thought process figured out here. So, can I turn pounds into grams? Yeah, that's pretty straightforward. That conversion we can look up. What about inches to millimeters, though? That's kind of weird. So I can look up inches to centimeters and then square that relationship, and then I can do centimeters to millimeters and square that relationship. So let's write those relationships down here. So 1 inch is 2.540 centimeters, which I can then square everything to get 1 square inch equals, I want to say it's like 16 point something. Oh, it's not. I'm not even close. Oh, that's because it's cubed. 6.452 centimeters squared. So that's this relationship. That's wrong. Hold on. We're just going to do that. This isn't a conversion that's on your metric table, but for the purposes of this problem, we know that there's 10 millimeters in the centimeter. And if I want to square those, I get that. So let's go up here and solve the problem. By first setting up our units. So I want to turn pounds into grams here. So we'll do that so these cancel. Put grams up there. Then I want to turn inches into millimeters. One step at a time. So I'll do inches to centimeters. And if I'm going to do the squared part, I got to take these numbers down here that I've squared. And again, you could have written that in parentheses, 1 inch equals 2.540 centimeters, and squared that quantity. Either way works. And then finally, we can do that. Oh, I started writing in the numbers while I was going. That was weird. So punch all those in your calculator, and it should make a smiley face. It will not actually do that. I got 12.4112. Looks like I have 4 sig figs, so 12.41 grams per millimeter squared. There you go. All right, let me look at these lab problems that I have here. I'm stuck between 2 different sodium solutions. So that is actually a problem that I realized after I videotaped everything. So here's the story about the lab stuff. I went in and didn't have all of the experiments already done for me, so I was doing them as I went. Like, I've done this multiple times before, but I didn't have all of them memorized. So I knew that there were certain combinations that looked pretty similar, but I didn't know which ones. So I picked a random sodium and 2 random nitrates. And then I got to the end and I was like, oh shit, this one looks kind of like the others. Or it looks like multiple possible answers. Now, you can narrow it down to 2 choices, I believe. And so if you are very careful, you will have 2 that you definitively know. One you should be able to identify very, very quickly without even looking at any of the reactions. The other one you can identify based on what the result does and what the other thing does, because you got to look for a pair. But the third one has multiple possibilities, and by multiple I mean there's 2 that it could be. And so I wrote a little bit in there. I said, if you have multiple possibilities, describe what they are, and like make an argument for why it's this thing or why it's that thing. And I'll give you credit for it because I realized that there were two issues. One is that I picked bad unknowns for this problem because I didn't want something that was not that unique. And then two, the camera wasn't very good when I brought everything closer because it looked great in the little viewfinder. Of course, I'm looking at this tiny, like 4-inch by 3-inch picture. And then when I go back and look at the footage on the PC, it's like, oh, wow, that's really blurry. Apparently there was a mode that I didn't toggle on for super close focus. So there are problems there, and I'm not going to hold that against you. So there is a correct answer, and I was able to determine it by looking very, very, very closely at like the color along the top of the solutions. 12.41 is the correct answer. That's what I have on my board right here. There it is right there. So, like, try to be as specific as you can. 12.58, that's pretty close. Double check that you didn't type in two numbers backwards or something. Like flip a 4 and a 5 or something somewhere. If you look very, very, very carefully at the solutions, you can make an argument for which one is the correct one, and it turns out it is the correct one. Based on, like, oh, it's this color, but there's a little hint of this at the top. Whereas in the other one that looks similar, it's actually got a little hint of a different seeming color at the top. So I'm going to pick this one. And it turned out that that was the correct answer. And I was very grateful for that because I did not expect it to actually work. I was just expecting, oh, I'm going to have to accept two answers for this. There's nothing I can do. And sometimes in science, that's what happens. But that's the story behind why did that happen in the first lab. It was Wes picked two chemicals to mix together. Here are the results. And then by the time he realized, oh crap, that's what the unknowns do, I had already recorded 3 hours of footage. So do the best that you can. But yeah, I recorded a lot of footage, and I chopped it all down to like whatever was in that video is like 5 minutes. So now I have a folder on my hard drive that has like 20 gigs of video of me just doing experiments, which I can now delete, thankfully. Get all that memory back. Or disk space, not memory. Oh, I made a mistake in my problem, didn't I? What does my calculator say for... Yeah, it says 6.452. I'm the one that made a mistake. So this number is actually flipped around. Oh, we'll leave it in blue. That's fine. Okay. So, just a heads up. I had a mistake there when I did this problem. Let me edit what my calculator says. Now I got 12.58, so... There we go. Thank you for pointing that out. Oops, we'll do that one in the right color. There you go. Alright, so that was a good use of time, I think. At the end of today's lecture, I do want to mention that the quiz key was posted last night. It should be open and available. If you have questions about your quiz 1 score, like why was this graded this way, I can answer those in private. Send me an email. I'm happy to do that. If you think that Canvas misgraded you for some reason, like you typed in a number and Canvas didn't parse it correctly, send me an email. I will check out what it did, and then I'll explain the result or correct it, because I can control what points are awarded for each problem individually. Just very important, if you are asking me to look at your quiz, make sure that you tell me what section you are, or email me from Canvas, because Canvas will automatically append what section you're in to your email. That's all I got. So if you have any last minute questions, let me know in the chat. Otherwise, we'll shut down the stream in a few minutes. Make sure to do the rest of those word problems on the worksheet. The worksheet's probably the best source of problems to practice for the quiz. The second best, I would say, is the workbook. If you are looking for more practice, you can pick up the workbook at the bookstore. That being said, I have learned recently, because a student asked, is there an answer key for the workbook? There is not actually an answer key, and I can't provide one, unfortunately. Email me with specific questions regarding quiz number 1 that has been graded and is available now for you to see. Quiz number 1 was the quiz that was due yesterday. Quiz number 2 is now available. And that's due next week. And then, of course, lab number 1 is due tomorrow. There will be a last call in the evening at some point. As long as you get the lab in by around like 11 p.m. or midnight or so on Thursday, that'll be fine. I won't download it until I go to bed, which will be much, much later in the evening, because I'm usually up until like 2 or 3 at least. And then I'll try and grade those over the weekend. Alright, where am I on this thing? Here we go. Yeah, okay. I think that that's all that we are going to do today, unless someone has a last minute question. So I'm going to put this up on the screen. Thanks for watching, everybody. Thanks for coming out. If you have any other questions, make sure to email me. Tomorrow we will do 2 units at once, units 4 and 5, because they're really, really, really short. So we'll see you for that. Bye, everybody.